afternoon or whenever you're watching this. We're going to go through our practice test for Unit 13, solving inequalities. Go through each problem, make sure you're ready for the test so that you can be very successful. Let's just start with number 1 here. Number 1 says match the graph with the correct inequality. So here's your graph. These are your options A, B, C, and D. If you look at your graph, important thing you want to look for is that we want to find our dot on the graph, where it is, which is right here. Okay, so that's at -4, so -4, -4, -4, +4, we can get rid of that one. Now we look at the dot, is it open or closed? It's closed, so closed can either be greater than or equal to or less than or equal to. Has to have that line at the bottom. So which ones don't have lines at the bottom? Well, there's no line there and there's no line there. That leaves us with x is greater than or equal to -4, which is B. So that would be our answer on this question. You can check it. Let's pick a number anywhere up here and see if it actually works. Let's pick the number 2 here. Okay, is 2 greater than or equal to -4? Yes, it is. We know that it is. So we can say that that is a correct answer. Good job. Number 2, what is the graph of x is greater than 5? Okay, so we said over here that we have to have a line underneath to have a closed circle. No line here, so closed circle, get rid of it. Open circle, closed circle, get rid of it. So you got 2 left. Our variable's on the left-hand side here, and so we can go with whatever way our inequality symbol is pointing. Since the arrow is pointing to the right, we have open circle, arrow to the left, arrow to the right, which means that our answer is going to be C. Let's check. Let's pick some of these numbers here. It's 5, 6, 7, 8, 9, 10, and so on. Let's pick number 7. Okay, original inequality. X is now 7. Is 7 greater than 5? Yes, it is. So we know that that is the right answer. It should be C. Let's get into some solving. Remember, when we have problems to ask us to solve inequalities, all we're doing is the same thing as if this were to read 20 equals -5x. You would do the exact same thing. Okay, so let's solve this, except first thing I'm going to do is I'm going to flip this around just so I have my variable on the left-hand side. And if you notice, our arrow is pointing to the variable, so let's make sure our inequality symbol is pointing to our variable still. Okay, now let's solve it. First thing to do is get rid of this -5. This is -5 times x. So I'm going to do the opposite and divide both sides by -5. -5 divided by -5 is 1. It's invisible. We just rewrite the x. 20 divided by -5 is -4. And if you recall, when we divide or multiply inequalities by a negative to both sides, this number down here is a negative, we need to take our sign and flip it around. So instead of x is less than -4, it's actually going to be x is greater than -4. X is greater than -4. And the answer is x is greater than -4. You could check it. Let's pick a number that's greater than -4. Well, 0 is greater than -4, correct? Let's plug it into our original inequality. 20 is greater than -5 times 0. 20 is greater than, well, -5 times 0 is 0. Is 20 greater than 0? Yes, it is. We just proved that this works. We're going to solve this inequality here. Again, it's the same as if I had x over 3 minus 9 equals 6. I would do the exact same thing, but we're going to do it with an inequality instead. Okay. First thing you need to do, let's get rid of this -9. -9 opposite is +9 or +9. Okay, we're going to bring our x over 3 down. These two cancel out. Greater than 6 plus 9 is 15. And this is division. X divided by 3, so the opposite of x divided by 3 is multiplied by 3. And we're going to multiply both sides by 3. My 3's cancel, left with just x on this side. I'm going to bring my inequality symbol down. I didn't have a negative, so it stays the same way. 15 times 3 is, that's right, 45. X is greater than 45 should be your answer. Which inequality has the solution of y is greater than or equal to 2? Y is greater than or equal to 2. Well, here's your options here. This one's a little bit longer of a problem. You could pick the first one and get it right away. Or you might end up picking the right answer, the last one, and have to do I'll have to do all of them. So let's just try the first one here. Let's solve the first one. 7y plus 9 is greater than or equal to 23. Well, let's subtract 9 to both sides. 7y is greater than or equal to 23 minus 9. What's 23 minus 9? 23 minus 9 is 14. Divide both sides by 7. Y is greater than or equal to 2. Well, that's nice. I did it on the first try, got the right answer on my first problem that I picked. Hopefully you did as well. So which inequality has the solution of y is greater than or equal to 2? Well, in this case, it was letter A. All right, we're going to write some inequalities here. Miss Lang had at least, that's an important word here, at least 50 minutes to grade her tests. If M represents the number of minutes, which inequality describes the situation? Okay, so M is our minutes. So minutes, do we have more than, do we have greater than, less than, greater than or equal to, less than or equal to 50 minutes? Well, we have at least. That means we could have 50 minutes. We could have 51, 52, 53, but I have at least 50 to do it. I could have more. So the minutes that I have is greater than, or it could be equal to as well, because at least 50. I have 50, I could have 51, 52, I could have 75, I could have 142. It doesn't matter as long as our number is greater than or equal to 50. At least. Remember, at least means greater than or equal to. You have to be younger than or equal to 11 years to attend elementary school. If A represents age, what is the correct inequality that represents this situation? So you're looking for your age, and you have to be something compared to 11 years old. Well, you have to be younger than or equal to. So what numbers are younger than or equal to 11? Well, 11 is equal to 11. What number is younger than 11? 10, 9, 8, so on and so forth. So A has to be less than or equal to 11. Okay, any number. Okay, it can't be -1, obviously, but -1 is less than or equal to 11, but age-wise, I can't be there. Okay, Paul delivers pizza during the summer. He earns $40 each day, plus $6 for each delivery he makes. Each day he makes at least $112. If D represents the number of deliveries he makes in a day, which inequality best describes Paul's situation? Okay, so we know he earns $40 a day, plus $6 for an unknown amount of deliveries. So we're just going to use D for deliveries. And we know he makes at least $112. Well, what numbers are at least $112? Well, we know 112 is at least 112. So do I go higher or lower? Is $120 at least 112? Yes, it is. And 120 is greater than or equal to 112. So this is the situation that you should have for this problem. $40 plus $6 per delivery is greater than or equal to $112. Awesome job. Let's look here. Let's solve this. 5 times the quantity x minus 6 is less than 25. Again, solve it just like you would a problem that says 5 times the quantity x minus 6 equals 25. first thing I want to do is I want to get rid of this 5, actually. I don't want to distribute it. I could, but I'm not going to. I'm going to make this nice and easy. First thing I'm going to do is I'm going to divide by 5 to both sides. If I divide by 5, that gets rid of this. And I have x minus 6 is less than 25 divided by 5 is 5. Next step, get rid of the 6, or get rid of the negative 6. And we're left with x is less than 11. And you're done. Let's try here. Let's combine our like terms first. Negative 6, 2f plus 4f is 6f is greater than or equal to 12. Okay, let's get rid of the negative 6 by adding 6 to both sides. Let's add 6 to both sides. Okay, cancel, cancel. 6f is greater than or equal to 12 plus 6 is, that's right, 18. And then our last step, divide by 6, and we're left with f is greater than or equal to 3. Notice I didn't divide by a negative, so my sign stayed the same. F is greater than or equal to 3. Solve. 6 is greater than b plus 5 plus 3. All right, let's combine some like terms. 6 is greater than b plus 8. 5 plus 3 is 8. Okay. Let's get rid of this positive 8 by subtracting 8. And we're going to get negative 2 is greater than b. Let's flip it around, put the variable on the other side. b is, let's make sure our inequality symbol stays the same direction as it is here. This says b is less than negative 2, so b is less than negative 2. And you're done. That's all it is. All right, let's go some absolute value questions here. Remember, with absolute value, there are 2 answers. Okay, it can have 2 different answers. Why? Well, the absolute value can be either positive or negative. So when we have the absolute value of x plus 2 equals 50, this answer inside here can be 2 things. It could be 50, which is 50 units away from 0, or negative 50, which is also 50 units away from 0. So we're going to have 2 different equations here. X plus 2 could equal 50, or x plus 2 could equal negative 50. Let's solve it. Subtract 2, subtract 2. You can do the same thing. X is equal to 50 minus 2 is 48, or x could also be equal to negative 50 minus 2 is negative 52. 2 different answers. Make sure you select both of these answers on the exam. 48 or negative 52. Let's try another one. Same thing. N minus 8 could be equal to 6, or n minus 8 could be equal to negative 6. Let's solve. Plus 8 to both of them. Okay. Negative 8 plus 8 is 0, so n is equal to 8 plus 6 is 14, or n is equal to negative 6 plus 8 is positive 2. Okay. You can check it up here as well. Let's put 2 in there. 2 minus 8, does that equal 6? Absolute value of 2 minus 8, does that equal 6? Well, the absolute value of 2 minus 8 is negative 6. Does the absolute value of negative 6 equal 6? Well, the absolute value of negative 6 is just positive 6. Yes, it does. It works. Okay, a couple different steps here. we got to get this absolute value by itself. Let's try that first. Okay, so let's get rid of this positive 8 first. If I want to get rid of that positive 8, I'm going to subtract 8. I'm left with negative 2 times the absolute value of x plus 4 equals 4 minus 8 is negative 4. Next step, got to get rid of this negative 2. I'm multiplying, so I'm going to divide instead. Those cancel. I'm left with the absolute value of x plus 4 equals negative 4 divided by negative 2 is just positive 2. Okay, so the absolute value of x plus 4 could equal 2. That means we could have x plus 4 equals 2, or x plus 4 equals negative 2. Let's solve. X is equal to 2 minus 4 is negative 2. X is equal to negative 2 minus 4 is negative 6. Again, two answers. Make sure you select both of these answers on your exam. Let's take this into an inequality world. Okay, we have absolute value of x plus 2 is less than or equal to 6. And we're going to solve it the same way, except now that we have the absolute value of x plus 2, that means that x plus 2, instead of equals, we're going to use the original inequality, is less than or equal to 6. Or we could also have x plus 2. Now, instead of doing the same inequality, we're going to flip it. And then we're going to take the opposite of 6, which is negative 6. And then you go through and solve it just like you would before. Subtract 2 to both sides. X is less than or equal to 6 minus 2 is 4. Or, same thing, x is greater than or equal to negative 6 minus 2 is negative 8. So x can be less than or equal to 4 or greater than or equal to negative 8. I can combine that into one thing. Let's do it this way. X is less than or equal to 4. I'm going to do the same thing. X is greater than or equal to, so I'm going to read it this way. X is greater than or equal to negative 8. Is that true? Well, you can check it on a number line. We're not graphing on this test, but you can do it. Okay? If I put negative 8 down here, put 4 up here, let's graph it. Okay, let's do the first one. We said x is less than or equal to 4. Okay, less than or equal to is a closed circle. And it's going to go this way. Or x is greater than or equal to negative 8. Again, a closed circle. And it's going to go this way. So you're going to figure out where do they share it in common? Well, that's all right here. That's our common spaces. And that's how you would see it on a graph. The reason why you can write it like this is because you have shared space on your graph. If they don't share, let's say this one went, let's use a different color. Let's say this one went this way, and this one went this way. They don't share anything, so that doesn't work. It wouldn't work like an inequality like this. But since they share them in the middle, we can write it like this, called a compound inequality. Let's try another one. Absolute value of x over 3 is less than 5. Okay, well, that means that x divided by 3 could be less than 5, or x divided by 3 could be greater than, we flipped it, and then negative 5, and we take the opposite. And we solve. Opposite of dividing by 3 is multiplying by 3. We're left with x, these cancel, is less than 15, or x is greater than negative 15. Can write it again together down here. X in the middle, so our first one is less than 15. or x is greater than negative 15. Let's see it on the number line one more time. And we got negative 15 down here, positive 15 up here. So our first one, x is less than 15. It's an open circle going this way. And x is greater than negative 15. It's an open circle going this way. Do they share space? Yes, they do, right here in the middle. So we know that we can write it as a compound inequality. And that's it. Hopefully that helped out. Make sure you study this great so that we can have an awesome test. I hope you're all doing well. Have a great day.